The next is a quick detailing of wind energy. So in non-conventional, it comes under non-conventional and renewable. Again, okay, India is among the larger wind energy producers. So rank mein matlab nahi hai because the ranks keeps on changing on 2 years. So it's generally among the top 3, top 5. Okay, India is among the large wind energy producers. As of now, how much are we producing? We're producing about 36 gigawatts. That's approximately 10% of our installed capacity, the wind farms. And Maharashtra leads in wind energy. In fact, 3 of the big large 5 are in Maharashtra. So some of the names of the large wind farms, 4, 5 names. The largest one is Mupandal. This is in Tamil Nadu. Okay, it has a capacity of 1500 megawatt power, Mupandal. Then we have Jaisalmer Wind Park. Its capacity approximately is 1275 megawatts. Then we have Brahmawel Wind Farm, Dhalgaon Wind Farm, Chakala Wind Farm, Vankus Wadi Wind Farm, and Waspet Wind Farm. Remember these, 7 of them. This is Tamil Nadu, this is Rajasthan, ये सारे जो है Maharashtra. Maharashtra is the leading state in wind energy. The largest one is Mupandal. 10% of installed capacity. 10% of installed capacity, approximately 360 gigawatts. 10% is wind. Why in Maharashtra? Because it has taken the lead in terms of policy. That's about it. As zaruri nahi hai, others we cannot. There was a time when Gujarat was among the leaders. Okay, but now Maharashtra leads in this. Yes. Okay, fine. That takes care of wind energy. Now let's move on. Now quickly, small discussions across couple of some other energy. So you all know about shale energy. So 3, 4 discussions bach gaye hain. Shale oil. Now shale oil is basically petroleum oil. What is it? This is petroleum oil in shale sedimentary rocks. It is the regular crude oil. It is the petroleum oil in the shale sedimentary rocks. Now, extraction from shale rocks is expensive. It requires a process called as fracking, where those gaps are cracked. Okay, it's fracking is a process. Now, fracking process is expensive. The US has presently the largest shale oil, and over the last 40, 50 years, it has developed technology for shale oil extraction. Okay. Presently, what we have is that shale oil is one of the reasons in reduction of oil prices from approximately $100, it came down to about $40, $50 because shale oil competed with Middle East. Okay, there's a lot of geopolitics involved here. So it's a type of a petroleum oil in shale sedimentary rocks, but the extraction of shale, from shale rocks is expensive. It requires a process called as fracking. By the way, I hope you know, India is a producer of a type of product called as guar gum. It's one of those products from India, from the forest, guar gum. Now, guar gum is used in fracking. I do not know the technology, kya technology involved hai, but India almost has a monopoly in production of guar gum, G-U-A-R. Like it is used in India, even Bangladesh has a good amount of guar gum manufacture. So fracking is a process some technology required for extraction of the oil जो बहुत महंगा है. Okay, and US has been exploring this right from 50s and 60s, almost 40, 50 years हो गया. They have been trying to develop this and they have succeeded. And when shale oil extraction became economical, the price of oil from Middle East, because of competition, the oil started reducing. So from as high as $100 a barrel, the oil prices came down to about $40, $50, $60 a barrel. So one big reason was the shale oil production from the US. This is the story of the US. Okay. Now, in India, there are reserves of shale oil. Okay, and shale oil, Andhra Pradesh में, shale oil Assam में, shale oil Meghalaya. There are reserves, and we started the exploration. But in 2019, last year, important development here. In 2019, okay, ONGC is the principal agency for doing all of this. This is after almost 5 to 6 years of investment. Okay, ONGC has declared that shale oil extraction is not viable. It has now abandoned the project. The India ka shale oil hai, that it is not economically viable to extract it. So shale oil के लिए 2019, ये 2013 में they started this shale research program, but in 19 last year ONGC declared that it is not viable. इसका दो reason है. They said there are 2-3 reasons here. One reason is Indian shale oil is in clay formations and difficult to extract. The second reason they said was Indian shale oil, this is tertiary in origin, unlike the shale oil in US, which is of Permian origin. So India ka shale oil jo hai, so the Indian variety is actually inferior. In 2019, ONGC again declared that it is not viable. It has kind of abandoned the project. It's not viable for India. And the reason that they gave was that Indian shale oil is in clay formations, and from clay formations, again, the fracking process hai, because of clay, or we call this as hydrofracking from clay, is uneconomical. It is in clay formations, difficult to extract. That the Indian shale oil is of tertiary origin. It is much more younger. The US shale oil is of Permian origin. The Indian is inferior. 5 to 6 years of investments. 2013 में we started this initiative. After 5-6 years of investments, ONGC says now we cannot do this. And the third reason they also said was poor support and poor ecosystem for research, for environmental clearance, and for processing and storage. This is actually the problems related to logistics and जो regulations हैं, they are not very conducive for the shale oil extraction. So Indian shale oil is in clay formations. Indian shale oil is younger, so it is of inferior quality. And important that the support systems, the regulations, the laws, the logistics, environmental clearance, technology, investments for technology, all of this is very poor. So we would rather focus on something else rather than develop the shale oil resources of India. The next one, a quick discussion on coal bed methane, CBM, coal bed methane. This is basically the methane gas in the coal seams. The coal ke layers hain, the methane gas in coal seams. The coal ke layers hain, within this coal there can be gas here, and this is formed under high pressure. It is a form of natural gas trapped inside the coal beds. India में the Gondwana coal is rich in CBN. The main areas are in the Damodar Valley belt, plus along Koel River, along Son River. These three areas have coal bed methane. Damodar Valley belt, Koel River. Koel River, okay, there are two Koel rivers actually. There is North Koel and there is South Koel. North Koel is a tributary of River Son and South Koel is tributary of River Mahanadi. Presently, there are 5 major blocks for CBM research and extraction. They are Jharia, Raniganj North, and Raniganj. We have Suhagpur, and we have Bokaro. Jharia, ONGC does the work. Raniganj also ONGC. Bokaro also ONGC. Suhagpur is with Reliance Industries. This is the private sector one. More or less good enough for a short write-up, a paragraph on coal bed methane. It is methane gas in the coal seams formed under high pressure. It is a form of natural gas. That's an important point. It is a form of natural gas. It's found in the Gondwana coal. The Gondwana coal is rich in CBN. Okay, I'm talking about Damodar Valley belt, in the Koel River, north and south, in the Son River. And there are 5 major blocks for CBM research and extraction. Okay, Jharia, Raniganj, north and south, Sohagpur, and Bokaro. Okay, nothing much to add. And you can just add one point that in India, there are technology limitations and also limited storage capacity. Much of methane, coal bed methane, is released, and coal bed methane is also responsible for coal mine fires. Please remember that methane is, जो methane gas है, CH4 methane, it is highly combustible, it is highly inflammable. So if you do not take care of the mines, if you do not take proper precautions, it can lead to mine fires. It can lead to mine disasters. In India, there is technology limitations and there is limited storage capacity. And much of the methane gets released. You can't trap it, you can't store it. Much of the methane gets released. And if you do not take proper precautions, it can lead to mine fires because this methane is highly combustible. That's good enough for few facts. Okay, ये GS में काम आएगा MCQ type of questions में. Okay, nothing much to add otherwise. Okay, the next one then in that case, what are gas hydrates? Gas hydrates ये काफी news में है. Gas hydrate is also called as fire ice. It's also called as fire ice. It's also called as methane ice. They're also called as methane hydrates. Okay, it's a very new resource that we are trying to tap into. Okay. Now, what is this? Let me explain this to you, please. Watch the screen. Okay, let me explain this to you. There you go. This is the surface of the earth and maybe oceans here. So methane is produced geologically. The geological reactions, okay, the rock reactions, the methane gas gets produced, rising, and on earth there are faults, there are cracks, and through these cracks this methane rises and comes out. Through these cracks it rises, comes out. But if there is water, if there is ocean here, or if there are permafrost conditions, basically very, very low temperatures and very high pressures. So at the ocean floor or below the sediments, okay, or in the permafrost. This permafrost is, okay, these parts of the frozen ground water, permafrost conditions. Temperatures again here is very, very low. So whatever methane is rising, okay, this methane gets trapped, okay, around water and moisture crystals. Okay, so gas is coming out, and because of very cold conditions and high pressure, this methane gets trapped in, okay, ice lattice. It gets trapped inside peculiar molecular arrangement of the water. And that's when it's called as gas hydrates. The gas inside the water. So write down two lines here that methane gas, when escaping and arising from Earth's interiors, can get get trapped in interlocking water molecules under very low temperatures and high pressure. Okay? The methane gas, when escaping and rising from the Earth's interiors, it can get trapped in interlocking water molecules under very low temperatures and high pressure. Such gas hydrates are common on deep ocean floors, under ocean sediments, and also in the deep permafrost locations. Okay, so I'm looking at locations like Antarctic ice cores. We are looking at Arctic regions, the deeper permafrost, rock beds, deeper permafrost, permanently frozen. So it's trapped inside that. Okay, that's why it's called as fire ice. They're like ice crystals, but they have methane. So gas hydrates are extremely unstable. Slight decrease in pressure and increase in temperature, methane can escape. That's why it's very tricky to extract it. The gas hydrates, they are extremely unstable. Think of it's like a cage, and inside this cage there is methane, and there is very high pressure, very low temperature. The methane is trapped. But the moment there is slight heating, the moment the pressure is released, okay, this methane can escape. Okay, so think of this condition where this is the ocean floor, and maybe I have these gas hydrates here. The moment I start drilling, the moment I start extracting, I'm disturbing the pressure and temperature, and this methane can now escape. Okay, so gas hydrates are extremely unstable. They're extremely unstable, and they easily escape when there is increase of temperature or there is release of pressure. Okay, so our basic point is it is difficult to extract. The resource is enormous. We have found enormous amount of resource, but it is difficult to extract. In fact, I would like to show this to you. Okay, this diagram, dekho aap. Look at this diagram here. Just a website I've taken up. So I've taken the website directly. Okay, so look at this. It talks about methane hydrate deposits below the sea floor. So there is a slow rise of methane because of thermogenic methane from below. Okay, please look at the slow seepage of thermogenic methane from below. It's rising up. In the Arctic regions, there is biogenic methane production. It is rising up here. It's very, very cold conditions, like a permafrost, okay, below the permafrost conditions here. So the methane gets trapped here. वैसे here also, while rising up to the faults, ocean floor में, there is some methane formed here, some methane formed here, and then you are drilling this out. So the moment the pressure, if you take it out a bit above or maybe disturb this area, the methane can escape. That's why it becomes tricky for this methane hydrate to be extracted and used. So get back on this. So back to our discussion. So gas hydrates are extremely unstable. Okay, with slight decrease in pressure and increase in temperature, methane can escape. The point is, it is difficult to extract. It's difficult to extract the gas hydrates. Now in India, the Bay of Bengal has one of the largest gas hydrate reserves. In fact, Bay of Bengal is the first place in Indian Ocean where they have found this. In India, the Bay of Bengal has one of the largest gas hydrate reserves. And offshore KG basin में है, offshore Kaveri basin में है, and around Andaman and Nicobar Islands. Okay, so we are researching on it. This is a very, very new area. We are still researching on it. India started research on gas hydrates in 1997. And now we have National Gas Hydrate Program. It's called as NGHP, National Gas Hydrate Program. Okay. So अभी कोई extraction commercial scale पे नहीं है, it's more of research going on. And one more fact you may remember, in 2019, okay, after we scraped off the Shale project in 2019, Oil Ministry has initiated a new resource assessment program, okay, for R&D on shale oil, coal bed methane, and gas hydrates. So more or less that much for the gas hydrates or fire ice methane hydrates in 2019. So it's a very old program we have been working with. 1997 में ये शुरू हुआ था. We have National Gas Hydrate Program NGHP. In 2019, Oil Ministry initiated a new resource assessment program. And this, remember, after scrapping the shale program. The shale program has been abandoned. दोबारा शुरू करना चाह रहे हैं New Resource Assessment Program, NRAP, New Resource Assessment Program for research and development for shale oil, coal bed methane, and for gas hydrates. So, fine then, that's for today. Okay then, take care.